Hello?
Hello.
Alright, so this is question 5 of the AP test review. This is a good question. You're always going to have a question like this. So one of these questions here will always be on the test. In some way, shape, it's the same type of problem. Like when we did there was a maximization, optimization. There is one with tables. You're always going to have those. Here it is right here. So let's go right here and start this off. So let's start off. It says let R be the region in the first quadrant enclosed by the graphs here and here as shown in the figure above. Find the area of this. So now if I'm doing the area, that would be top minus bottom, right? So it'd be area of the top, which is, so it would be integral, right? So where am I starting?
From
0 to 9. Okay, so the top is going to be x 1/2 minus the bottom, which is x over 3, and that's going to be dx. Now,
Her Majesty.
what? Do you mind? All right. So from right here, we have when you're writing it out. This is super important here. Okay. So when you're writing it, if it's not clearly, this is something that you should add to it. Okay, parentheses around both parts of the function. Okay, parentheses around, and then you have your dx on the outside of that. So we're going to go ahead and do my integral of this now. So I'm integrating, so x to the 1/2 is going to give me x to the 3/2 and 2/3. And I'm going to have minus x squared over 6 from 0 to 9, right? Yes? Okay, good. All right, so let's go ahead and start entering these in. So I'm going to end up with, this is going to give me, so top of the 9. So it's going to be 9, so square root of 9 is 3. 3 to the third is 27. 27 divided by 3 is 9. Times 2 is 18. There we go. Yes. All right, and then minus. So 9 squared is 81. 81 over 6 reduces to 27 over 2.
Mm-hmm.
Yeah, so we have 27 over 2. Minus the lower bound. So my lower bound is going to be zeros. So it's going to be 0 right here. So that's 0 minus 0. So 0 minus 0. Okay, so now let's see. That's going to be 18, which is 36 over 2, minus 27 over 2, which is going to be a positive 9 over 2.
Yeah.
And do I have any units here? Yeah, it's just going to be units, or units squared. But you have to pay close attention to, if it's giving you stuff, it's giving you values, look at your charts, you're going to have to label it units. Okay, that's going to be key. That's usually like a whole point off of this. You want to get all your points wherever you can. So this is going to be just my units squared. Okay, if it's a word problem and they actually start talking about something, explain what it means in terms of the story of whatever that word problem is. Okay, if it's watermelons or whatever, that a lot of math problems, have millions of watermelons, over time.
I just have a quick question. Is it better to just keep it u squared, or would you rather us write like unit squared?
U squared is fine.
Okay.
You could write unit squared. It's already an assumed thing that U is an abbreviation of units.
Okay.
So like if you put FT, it's known that it's for feet.
Okay.
Okay. All right. So let's take a look at numbers now. Numbers. So this one. So as I set up my integral right here, this is 1. Let's see, next one, it's going to be, if I do my integration correctly, that's also 1. And then my last answer is also 1. So this question right here is worth 3 points. Okay.
Okay, I guess.
It's doggo.
Okay. So, all right, let's go to the next part. Part B. Part B. Write but do not evaluate expression involving one or more integrals that gives the volume of the solid generated when r is revolved around the horizontal line y equals 4. Okay, y equals 4. So first, I'm going to go 1, 2, 3, 4. So I am going to draw that in there, right there. If it's revolving around that, I need to start with the formula for the revolution. Okay? The formula for the revolution is always going to look like this. It's going to be pi, right, from A to B, yes?
Yeah.
Of my f of x squared dx. This is the basic formula, right? This is basic. But now we have to look to see what we're doing here. So now, if we are revolving around a line that is parallel to the x-axis, okay, that's going to still be dx, isn't it? Say yes. Okay, that one's still going to be dx. Still going to be dx. So now let's, I'm going to start plugging in my formula, what I have. So now, if it's revolving around this, that means that my radius is going to be this one, right? From there to there, minus my inside, which is there to there. Okay? So the outer of my function would be what?
4 minus x over
No, just the outer. I just want...
x over 3.
Okay, so I get my x over 3, right? Now, to figure out the distance from here to here, it's going to be a subtraction. Because I'm going to subtract this piece right here. So it's 4 minus whatever my function is. Does that make sense? If you draw it out and actually like draw your lines for your radius, this is so helpful. It really is. Like, I'm telling you, I used to, and I still kind of struggle with this. I have to draw this, even for my sake. And I've been teaching this for, 6, 7 years now. I always have to draw this. I have to draw it out. I have to list it. I have to see a visual of it to actually help me to be able to solve this. So I know that in my function, it's going to be pi from some values, and then my function is going to be 4. So it starts with a 4 minus my value, which is x over 3, right? Squared. Okay? That's going to be a dx, right? Say yes.
Yes.
That's a dx. And my bounds. What's the bounds going to be? Okay, the region, so it's going to be from 0 to 9. 0 to 9. 0 to 9. Minus my inner. My inner, same bounds. So the inner would be, again, same thing. So it's going to be 4 minus my function, right? So it's going to be 4 minus the square root of x. There we go. I like having this in separate, clearly separate, defined functions. Okay, you could actually have it as one function of just top minus bottom, but then you have to make sure that when you do your square, you're actually foiling both of those functions. Okay, that's important. You have to FOIL it. Because this is a binomial here, I need to FOIL it out. If it was a trinomial, I'd have to distribute all the way out. So in this one right here, we need to go and do that. So since I'm going to use the fundamental theory of calculus and put these both together, so I'm going to pull out my pies, right? I'll pull out my pies, and it's going to be from 0 to 9. So let's distribute this one right here. So if I distribute this one, it's going to be 16. So it's going to be this times 2, which is going to be minus 8x over 3. So I'm doing the distribution, and the next one right here is, it's right here, I'll put them away. And then it's going to be plus x squared over 9. Thank you. Okay, minus. Now, this is important. This is where a lot of people are going to screw this one up. Okay? So, do you want me to actually do the foiling? I just did a like a trick to go along with this. So what you can do is, because I know it's going to multiply by itself, right? So the first times first is going to be 4 times 4, right?
Oh, yeah.
And the last times last is going to be this one times itself, right? So it's going to be x squared over 9. That's why I get there, right? But if I distribute it, it's going to be a 4 times the negative x over 3, right? That's my first middle term. And then my second middle term is going to be negative x over 3 times 4, right? So I'm going to get both on there. I'm going to get that twice, right? So it's going to be 2 times the middle terms together. So here, I'll show you here. So 4, that was just the trick, and trying to save you a little time so you don't have to write it out. No, not for me. Not for me, but for you guys, when you're taking the test, it's a trick that's going to help so you don't have to go through and do all that. Okay, so first times first gives me 16. First times last is going to give me negative 4x over 3. Negative 4x over 3. And last times last is a positive x squared over 9. So now, because of this right here, I'm going to have 2 of these that are exactly the same, right?
Yeah.
So 2 of those together is going to give me 2 times that, right? So my trick to this is this times this. So this times 2.
Yeah.
Because I'm going to have 2 of those. And that's the reason why I was able to go straight to that. All right, so I'm going to have you actually try this next one to, because we have another one where we have to do that one over there too. So like I was saying, this minus sign means I need to subtract the whole function.
Yeah.
So I need to put a parentheses right there. So it's going to end up changing my operators. It's going to change my signs for all of it. All right, so now, okay, you ready? You are going to tell me what I'm writing for this next one. So I'm doing this one. So I'm going to write what? 16. Oh, hold on.
4x.
It is
4x.
4x to the negative 1/2, right?
Yeah.
Okay, so it's going to be this times this, and I'm going to have 2 of them, right?
Yeah.
So in our FOIL, my middle terms are going to be both the same, aren't they?
Mm-hmm.
So it's times 2. So it's this times 2.
Okay.
So what do you get? 8 x 1/2. And my last term? Last times last.
X. Yeah.
Yeah, plus x, right?
Yeah.
Okay, there we go, plus x. And then there's my dx. Yeah, like I said, it's just a neat trick. So it's learning stuff like that is to help you, you know, if it saves you 30 seconds to a minute on your stuff, you know, that's great. That means you have more time to actually think through
Yeah.
the problem itself.
I'm not a visual person, so I have to.
Okay, yeah, yes. All right, so, okay, so let's go through, and I'm gonna do my distribution.
But do we need this? It says like, yeah, it says to not evaluate
There's
and
no way.
express. So can we stop on the
I-
first slide?
Yeah.
Okay.
So we could have that, or we could have this all the way, right?
Okay.
Oh, but okay, I didn't see that, but.
Yeah. Do not evaluate. So all I was doing is actually setting up the whole problem. So we're not evaluating it. So my points on this one are as such. So as long as I get this, my bounds will give me 1 point. And my setup, which is the 4 minus, okay? So all this in the middle, as long as you have it all set up, is going to be worth 2 points. It's 1 for each side.
Wow.
Huh?
Thank you.
Are we okay? All right. Next one, part C. Find the maximum vertical distance between the graph G and the graph H between x equals 0 and x equals 16. Justify your answer. Okay, so distance in between the graphs. How do I find distance in between the graphs? Yeah. Okay, it should be top minus bottom. So in this one, it's going to be maximum distance. So it's going to be d of x is equal to the top minus the bottom, which is x to 1/2. Right? Hey. Okay, so top minus bottom, right? So if I'm, here's the key word, maximizing,
Oh, God.
what do I do? Maximizing.
So it equals 0?
Derivative, right? Derivative equal to 0. So those are my mins and maxes, right? Mins and maxes are derivatives equal to 0. So I need to take the derivative of this now, right? So if I take the derivative, so that's going to be my distance d prime of x is equal to minus 1/3. 1/3, right? Set it equals 0, so now I'm going to have 0 equals 1 over 2x 1/2 minus 1 over 3. There's a couple different ways of trying to isolate this one.
We just put the 1 over 3 on the left. And
Yeah, you can. So it's like 1 over 3 equals 1, 2x 1/2 times 2. 2 over 3 equals 1 over x to the 1/2. Now, I'm going to have to like move sides on this one right here because it's in the denominator. So multiply both sides by x to the 1/2, right? Times 2 over 3 equals 1, right? Now, how do I undo this from the left-hand side? Divide both sides, right?
Yeah.
Or multiply with the reciprocal? Yeah, so it's going to be on the other side, it's going to be x to the 1/2 is equal to 3 over 2. And, yes?
Yeah.
And then from here, how do I get rid of a square root? Square both sides. So x equals
9 over
9 over 4. X is equal to 9 over 4. Okay? So that's either going to be a minimum or a maximum, right? Okay? So that's part of my optimization. So it's mins and maxes, derivatives equal to 0. So let's go ahead and check that. So I'm going to see where d of 9 over 4 is Alright, so that means I need to plug it into D, right? So that's going to give me the distance, the furthest distance or the least distance. 9/4, so plug it in here. So let's do the math. So it's going to be 9/4, 1/2 minus 9/4 divided by 3. So it's 3/2 minus, so that's going to be 3/4. Yeah, 3/4. Yeah, because it's going to be 9/4 times 1/3. Yeah, so it's 3/4. So that's going to be 6.
9 over. That's gonna be 3/4.
Yeah, so it's 3/4, and this is one of my values here. So I need to check the other ones.
0 and 16.
Now, what other values do I need to check here?
0 and 16.
0 and 16. I gotta check my endpoints, right? So I have to check the endpoints. Since they gave you bounds here, okay, we gotta check both the other ones. So 0, so I have to do D of 0 and D of 16. So D of 0 should be easy, right? 0. D of 16, so let me see, that's gonna be,
4/3.
so it's 4 here, right? And it's minus 16/3.
I'm gonna be negative. That's why I think that's
Okay, so, and we're talking about distance, right?
Yeah.
Distance, so it could be a positive or a negative, but it's still a distance, right? So it just depends on the direction that I'm going. So this is gonna give me, what's that? Let me see, that's 6 times 3, 12. That's negative 4/3. Alright, so the maximum distance right here is gonna be when D of 16 equals negative 4/3 is max distance. So the actual distance is going to be 4/3. So you can do it, set it up as the absolute value, or you could just say, you know, negative 4/3 is the max distance. So that's going to be greater than my 3/4 here. So let's look at numbers now. Okay, so now if I do this, I get 9/4 is 1 point. I set my derivative equal to 0 is another point. And my explanation down here, it has to be an explanation. So this right here is also 1 point.
1, 2, 3, 4, 3.
3.
I don't know why it says it's the max distance.
You have to state that.
I know.
Okay, because when we're optimization.
Asking why I didn't get one.
Okay. All right. Are we okay? All right. So instead of doing 6, I think it's more productive. Tomorrow I'm actually going to do more of these problems. I want you guys working on those multiple choice problems. We're going to use the time and then, so do a problem, do a couple problems, then I'll let you check answers.